Good evening. David de los Reyes, February 16, 2022, Los Angeles. Okay, my discussion tonight is integration by algebraic substitution. I will give you more examples. Okay. This is a continuation of my integral calculus topic on my channel. This is lesson 32 on integral calculus. The topic is integration by algebraic substitution. Okay, this will be part 2 on the example evaluations. Okay, let's proceed with the example number 1 for tonight. Okay, the given problem is the integral of quantity 4 minus x, x to the 1/3 dx equal to. Let's try to bring out the solution of this by using algebraic substitution. We let z equal to x raised to the 1/3. We let this one to be z. Okay? Why x to the 1/3? As we look at it, the given problem, the more complicated one is this one than this one. This is just linear, and this one is under the power exponent. So from the look of it, it's more complicated. So we will try to bring out an algebraic substitution representing that one. And we let z equal to x raised to the 1/3. You can take any variable. It could be y, but for the meantime, we will use z. Okay? Proceeding with the solution. Take or raise both sides of the equation to the 3rd power. Okay? Z to the 3rd power is c cubed. X raised to the 1/3 raised again to the 3rd power. These 3 here cancel with this. So what will remain on the right hand side is just simply x. Solving for x, okay, x will be c cubed. Okay? X will be c cubed. We just rearrange. Take the differential of both sides. The differential of x is dx. The differential of z cubed power formula, 3z squared dz. Okay? So we are now given the value of dx in terms of the new variable. We substitute it to the original equation. That's why the topic is algebraic substitution. We substitute, okay, the resulting equivalent of the integration as a function of the new variable z. Okay, I will repeat it. The integral now of quantity 4 minus x, x to the 1/3 dx is equal to the integral of the quantity 4. What is x? It is c cubed. So this is minus c cubed. Okay? Close quantity. Times, what is x to the 1/3? X to the 1/3 is z. Right? And what is dx? Dx is 3 squared dz. 3z squared dz. Okay? Expanding. This 3 here is a common factor. I bring it out. Times the integral. Okay, 4 times z times c squared is 4c cubed. Minus c cubed times z times c squared. 3 plus 1 plus 2, this will be 6. closed quantity dz. Okay? Expanding, 3 times 4 is 12, we bring it out, so this should be 12. The integral of c cubed dz, okay, minus 3, the product of this, the integral of z to the 6 dz. Power formula. The significance of this, after the substitution, okay, and the expanding and simplifying, what comes out is actually this one here. And from the look of it, it's just under the power formula. Okay? This is power formula, power formula. The value of u here is z, du is dz, exact. The value of u here, recall the integration formula. Du is dz, it is exact. So it falls under the power formula. Right? So this should now be 12, okay, z raised to 3 plus 1, which is 4 over 4, minus 3, z raised to 6 plus 1 is 7 over 7, plus c, right? Then, but what is z? What is z? X to the 1/3, right? Right? So to bring out the solution now in terms of x, we will let z equal to x to the 1/3. This is the original substitution, right? So this will be 12 over 4 is 3, x raised to 1/3, this is z. Raise that again to the 4th power, minus 3 over 7, okay? Times z, x to the 1/3, raise that again to the 7th power, plus c. Final answer, this will be 3x raised to 1/3 times 4 is 4/3, okay, minus 3 over 7, 1/3 times 7 is 7/3, let's see. So final answer, it will be 3x raised to 4/3 minus 3 over 7, x raised to the 7/3 plus c. That's the final answer in terms of the original variable x. As simple as that one. That's algebraic substitution. It's easy, right? Okay, let's continue, guys. Example number 2, a little bit complicated. The integral of x cubed times the quantity 4 plus x squared raised to 1/4 times dx. Okay, so it's up for you guys to represent the algebraic substitution. But in here, I lead z, I'll go to my right, I lead z equal to quantity 4 plus x squared to the 1/2. There is no quantity like this on the given equation, but this is similar to this, right? Okay, I just want it to be 1/2. There's no problem with that one. It's just an algebraic substitution. Okay? So if z is equal to the quantity 4 plus x squared raised to the 1/2, squaring both sides, z to the 2nd power is c squared, right hand side raised to the 1/2 quantity squared, these two here cancel with this. Right hand side will just now be simply 4 plus x squared, or we put this on the left, or 4 plus x squared equal to z squared, right? I just rearrange it. And if we try to compute for the value of x, okay, if we try to compute for the value of x here, x squared equal to c squared minus 4. Okay, solving for the value of x, raise both sides to the 1/2. x squared raised again to the 1/2 power, this 2 here cancel with this. So x now will be equal to z squared minus 4 to the 1/2 is just the square root of c squared minus 4. It is this. Right? Where are we? Oh, 0. Differentiating both sides. I'm not tricked. It seems my view is different, okay? Try to take the differential of this to bring out the x. The differential of 4 is 0. The differential of x squared is 2x dx. The differential of c squared is 2z dz. Power formula, this is pure constant. 0, 2x dx equal to 2z dz. Okay? Or 2x dx equal to 2z dz. This 2 here cancel with this, or it seems 2 is gone, right? Solving for dx will be z dz. Actually, you multiply this by 1 over x. Right? X dx times 1 over x, x here cancel with this, left hand side will be dx equal to z dz over x. But what is x? Okay, this is x. So to compute for the value of x in terms of only variable z, it will be z dz all over the square root of c squared minus 4. Right? I will erase it. Okay? Let's try to continue, guys. I just erased because I want to show something over here. So, to continue with the solution, therefore the integral of the given original function x cubed quantity 4 plus x squared raised to the 1/4 dx equal to the integral. What is x? X is actually z squared minus 4. Okay? Z squared minus 4. Square root is raised to the 1/2. But this is raised to the 3rd power times the equivalent of this. What is 4 plus x squared? 4 plus x squared is c squared. So this is c squared. Okay? This should be raised to the 1/4. Sorry for this one. I'm just following this. Because this value here is c squared. So this is c squared. Raise that again to the 1/4 power times the value of the x. The value of the x is c dz all over the square root of c squared minus 4 close bracket. Okay? So it's just a matter of simplification. Okay. Look at here, guys. C squared minus 4 to the 3/2. This can be written as c squared minus 4 raised to the 2/2 multiplied by z squared minus 4 raised to the 1/2. These are the same. Why? Same base. Okay, so the same base. Okay, so if we try to compress this one, it will be same base plus add the exponent. 2/2 plus 1/2 is 3/2. So z squared minus 4 raised to the 3/2 can be written as c squared raised to the 2/2 times the quantity c squared minus 4 to the 1/2. Where is it? It is this. Right? And z squared raise that again to the 1/4 power. That will be c to the 1/2. because 2 times 1/4 is 1/2, right? So this is z to the 1/2. It is this. Z. What is z? Z is actually z to the first power. What's first power? 2/2, right? Times dz all over the square root of z square minus 4 is actually z square minus 4 raised to the 1/2. So, you now know the significance why I converted this one as a product of two functions, because I want to cancel something. Actually, this one here cancel with this. They are the same, right? The operation on the numerator is multiplication, okay? All over a common denominator. So actually, this term here cancel with this. So what will come out, this will be the integral. What remains is just this. This is gone, right? Times 1. Times z to the 1/2 times z to the 2/2 is same base plus add the exponent. 1/2 plus 2/2 is 3/2. So this is z raised to the 3/2 dz. Right? It is more simpler now. Yeah. Okay, I will continue here. So if we try to expand, okay, c square times z to the 3/2 is actually c square multiplied by c to the 3/2. Okay, this is fraction, so I will multiply 2 here over here, so this will be c square is actually 4/2, right? Right? Same base. So it will be same base. 4/2 plus 3/2 is 7/2. It is this. Right? And the second term, stand alone. 4 times z to the 3/2 dz. This is 4, I bring it out. The integral of c to the 3/2 dz. Right? So, they are both under the power formula now. Okay? The value of u here is z. du is dz, this is exact. The value of u here is z again. The value of du is dz, this is exact. So, we will just recall the power formula. So, the final answer will be z raised to 7/2 plus 1. But what is 1? 1 is 2/2. All over 7/2 plus 2/2. Minus 4 raised to z raised to 3/2 plus 1. But what is 1? 2/2. All over 3/2 plus 2/2. Close quantity plus c. So it's a matter of simplification. 7/2 plus 2/2, same base, add the numerator, this is 9. So this is 9. This should be all over 9 over 2. But this 9 over 2 is on the denominator, so to bring it up, we will take the reciprocal. So the coefficient of the answer now, first answer now will be 2 over 9. Quantity, what is z? Z is actually 4 plus x squared raised to the 1/2. And raise that again to the 9/2. Right? Minus 4. 3/2 plus 2/2 is 5/2. We take the reciprocal, this is 4 times 2 over 5 times the value of z. 4 plus x squared raised to the 1/2, raised that again to the 5/2. I think you cannot see the bottom portions. So the final answer for this, it should be 2 over 9, okay, times 4 plus x squared raised to 1/2 times 9 over 2 is actually 9 times 1 is 9, 2 times 2 is 4, so this is raised to the 9/4. Plus, okay, this minus. 4 times 2 is 8, all over 5, okay, times 4 plus x squared. Okay, that's the value of z. Raised to the 1 half, raise that again to the 5 halves. 5 times 1 is 5. Right? And 2 times 2 is 4. So this is 5 fourths plus c. So this is the final answer. Okay? 2 over 9, quantity 4 plus x squared raised to the 9 fourths, minus 8 over 5, quantity 4 plus x squared raised to the 5 fourths, plus c. You cannot see it, this is too low. 2 over 9 plus 8 over 5. This should be minus. Second one should be minus. Minus 8 over 5. First one is plus. Okay? That's the final answer, guys. So it's just a matter of algebra. After the algebraic substitution, it is now integrable. A matter of simplification, the final answer will be 2 over 9, quantity 4 plus x squared raised to the 9 fourths, minus 8 over 5, quantity 4 plus x squared raised to the 5 fourths, plus c. That's it for tonight, guys. I've given you already 4 examples on algebraic substitution. Next lesson, integration by trigonometric substitution. Good evening, Los Angeles.